Great, welcome back. So with this tutorial, we'll be covering the Trading API and specifically automating Darwin executions via the Trading API. Immediately visiting the specification that you can access via the api.darwinex.com portal and subsequently by clicking on the Darwin Trading API section, the first thing you'll notice instantly in the API console is that there are two additional request types to consider for implementing the Trading API, these being put and delete. And why I say two additional is because up until now in all the APIs other than the Trading API that we've been working with, as you'll know if you've been following along in the source code, that we have implemented post and get requests only. So for this tutorial, before we cover anything else, let's go into DWX_API, our parent class that is the backbone of every single class that we've constructed for every API so far. And we've added two additional request types for you. They're implementations here in DWX API and already uploaded this code to GitHub for you to use immediately should you wish to do so. These include the put and delete requests, and it's fairly simple to implement them. So they follow almost the same format and use the same headers, of course, in terms of authorization, the bearer tag being mandatory. And post headers and put headers are the same in this implementation. So instead of creating additional headers for put, we've simply used post headers here for the put request. With the delete request, again, it does not require any additional headers other than authentication headers, and it does not require data to be submitted either. So here we're very simply creating the endpoint, constructing the path appropriately in the endpoint depending on what we want to use the delete request for, sending off the query and getting the results back in similar fashion as before. So that has already been implemented for you, and you can take a look in your own time when you get to the code repository on GitHub. Now heading back to the Darwin Trading API, let's talk about the functionality available to you in the Trading API and how to implement it in Python. Well, at least how to understand the code that's been implemented for you in Python so you can extend it or integrate it or use it as is. Visiting the API console, you'll immediately notice the put and delete request, as we talked about, that have been implemented for you. And the methods that have been provided to you in the Trading API include raising a conditional order, updating that conditional order. Let's go into raise a conditional order to see what generally the specification in terms of input parameters arguments follows. So as before, as we saw in the investor account info API, here for each operation you need to provide an investor account ID followed by the subject in question. So in this case, if we're raising a conditional order, then we need to provide a conditional order object. This will be a dictionary object in terms of Python, where you'll need to construct the dictionary object to contain the following information: the amount that you'd like to purchase, the product name being the full Darwin ticker symbol on which you'd like to execute that volume, the quote at which you'd like that conditional order to be, the side at which you'd like it to be. Of course, in Darwin's case, it's simply buy, and the type. So less than equal implies that you're executing a buy limit order here, because here you're specifying a buy price in the future that is touched when the price either hits it or goes below it. Threshold parameters include your conditional orders for stop loss and take profit. So with this complete dictionary object, you're specifying the amount, the Darwin ticker symbol, the quote at which you'd like the product to be purchased, the side, which is buy, less than equal implying that you're submitting a buy limit order, threshold parameters meaning that once the order is in execution, you'd like a stop loss conditional order to be present at price X, in this case 10.05, and the example provided to you on the API console, and the quote take profit being at 250.1 in this case, these being example values on the API console. But this is essentially the dictionary object that you need to construct by providing this information. And then you pass that dictionary object as JSON to the API in the form of data supplied via post. And that's how you raise a conditional order. We'll go into the specification, the actual implementation here shortly. You can also update any submitted conditional order by executing conditional orders / the conditional order ID. Now remember, we covered getting conditional orders by status in the previous tutorial on the investor account info API. Here, therefore, you'll need to rely on the investor account info API for two things, primarily, these being the investor account ID. If you don't know the account ID by heart or haven't stored it somewhere, then you can, of course, execute get accounts, and that will return to you a list of available investor account IDs given the client ID and client secret that you've used for either your demo or real account connectivity. Once you've got the investor account ID, then in order for us to do anything with existing conditional orders, we need to have their conditional order IDs. And these are available to you via the investor account info API, where we developed a function to implement the endpoint that allows us to get conditional orders in a few ways. One is if you already know the ID, which in our case right now, we're going to assume we don't. And the other is by status. So if you know the status of the order, for example, pending or executed or whatever, then you can specify the status, the Darwin, if it's a particular Darwin you're interested in and you know of that has orders in execution or in some status on your account, and then that essentially returns to you the conditional order ID, then that you would then go on and use via this endpoint here for update or for cancel existing conditional order. You'll notice that the update existing conditional order has a type put. So in order for us to process this, we'll need to construct data for it. And this data will essentially take a few fields compared to the previous raise a conditional order method. Here you'll need to provide the amount, the quote at which you'd like that to be executed, the threshold parameters, and the quote stop loss and quote take profit. Basically, if a conditional order is pending, which is the only way you can use the update conditional order endpoint, then if you've already previously provided an amount and a quote at which you'd like it to be affected, as well as quote stop loss and quote take profit, you can change these values. Now, from an algorithmic trader's perspective, you have a few use cases here in order for you to consider. So, for instance, you may possibly be looking at some sort of trailing setup whereby you're following the Darwin's quote, and you have some analysis that determines that at some level your Darwin is likely to be at a favorable price according to your strategy or analysis or whatever it is that you've done to arrive at that conclusion. You can then use the conditional order update method here in order to follow the quote of the Darwin to such a level. So similar to, say, a trailing stop or a trailing take profit sort of functionality that you would develop in any other asset class. That knowledge is equally transferable here to Darwin assets via this method as well. So in a nutshell, you'll need to submit a put request with this constructed data that essentially affects changes to your existing conditional order. At this point in time, you can only use this method for conditional orders that are in status pending, meaning they haven't been touched and hence executed onto the market. Finally, you have cancel an existing conditional order, and that too can only be done on orders that are pending, as in they haven't been executed and you can still make changes to them, including getting rid of them. The request type on this cancel existing conditional order is delete, and again, this can only be affected on orders that are pending and have no other status. There are also some additional methods that allow you to get and set leverage on the account. So by default, your leverage is 1, which you can obtain by calling the /leverage endpoint. If you'd like to set this value to a different value, then you can update the leverage on the account by submitting a put request, whereby you construct a DTO as we did before, specifying simply one parameter in your dictionary object, the leverage, followed by the value that you'd like to add onto it within the limitations that you have on our platform. Right. Finally, we have the actual orders, how to buy and sell Darwins. And selling is only limited to, well, if you already have a Darwin in execution, then at this point in time, you can sell that order or some volume of that order, depending on your use case. With orders by, you'll need to execute the /orders/buy endpoint. And again, you'll need to construct the order in the form of a dictionary object, a DTO. Inside this order, you're going to specify the amount, the product name, which is the full ticker symbol for the Darwin that you're interested in, and the threshold parameters if you'd like to specify a stop loss and or take profit on it. Once you execute this dictionary object, your quote stop loss and quote take profit will result in the creation of 2 conditional orders on the platform to specify the stop loss and the take profit. And that's essentially it. That's how you submit a buy order. These, however, are different to conditional orders in that once you submit a request through here, the order is assumed to be at market. So once you use the /orders/buy endpoint, you won't have the flexibility of buy limit or buy stop orders. You will go into market straight away at the first available quote that is there at that point in time. Then for sell, it's again sell a product at the current quote. So the specified leveraged amount is sold. In the case the market of the underlying instrument is closed, the operation will return anyway, but it will take a while for the funds to be back in the investor account. Now, again, you need the investor account ID, and you need to create a sell order dictionary object whereby you very simply specify the amount that you'd like to sell of the Darwin. That can be all the way up to the full amount invested in the Darwin asset. And you'd also need to specify the product name, which is the full ticker symbol of the Darwin in question. Finally, you have 2 features to allow you to control the activity of your Darwins in sort of kill-all fashion. So stop out there are 2 types of methods for stop out. One is stop out on a particular Darwin, and the other is the nuclear option, which is stop out on the entire account. Executing stop out will result in all trades on the account being wiped out, as in closed at the current quote at the point at which you executed /stop out. This will essentially sell every single Darwin that currently exists in the portfolio. For you to be able to do this, you very simply need to provide your investor account ID to the /stop out endpoint, and that will result in the closing of all investments on the investor account that you specified. If, however, you'd like to stop out trades on a particular Darwin, which has several use cases, you might have a strategy that follows certain Darwins. You might have more than one strategy operating on your investor account. In those cases, you'd only want to perhaps you have some sort of criteria where you need to close all investments on a particular Darwin based on your strategy. In those cases, you could execute /stop out /product name, given the list of Darwins that satisfy your closure criteria, and that would essentially close all trades on your investor account for that particular Darwin. And in that case, you'd need to supply your investor account ID as well as the product name, this being the full Darwin ticker symbol, to your endpoint. And this is a post request. The output will be very simply an acknowledgement or an error, depending on how the query fared. So 200 is essentially good. Everything was done as you requested. 401 is unauthorized, 403 is forbidden, and 404 is not found. Finally, we have the product market status endpoint, which essentially returns to you all the currently available operations on Darwin. So this will include, can you buy, can you sell, and can you submit buy and sell conditional orders. This will return a dictionary object that will have true or false depending on the value that is currently associated with that particular operation, given the time at which you've requested it. Usually these will all be true. And that's essentially it. So those are the core features in the DARWIN Trading API. We're now going to take a look at the source code and how we've written it, again, in similar fashion to previous tutorials where we inherit things from our parent clause, DWX API, to do all the underlying lower level operations such as post, put, delete, get, handling request types, submitting data, automatically getting authorization tokens, constructing headers on the fly, so you don't have to worry about those things in your API implementation as regards the DARWIN Trading API. Each of the endpoints that we discussed just now have been implemented again in a inherited class here. We've inherited all the features of DWX API to give us all the authentication and header construction features to send over to the endpoints. And we've implemented each endpoint as a function. Again, it is not necessary for you to implement each endpoint as a function. This has been done for completeness to explain how things work, and so we can also test them here for you during the tutorial to show you how they work, flipping to and from the platform pages to show you the orders in execution, updates we make to the orders, etc. So let's go ahead and try everything to demonstrate how it all works and and more importantly, how you'd incorporate this into your automated trading strategy to do with Darwins if you're creating one. So we have get permitted operations, which sends off the call to the product market /status endpoint. get account leverage to /investor accounts /leverage after your investor account ID. Then we have a few functions to generate some dummy orders for us. And these dummy orders will be here for example purposes, so we can demonstrate to you how these functions actually work. These are dummy orders, meaning please do not use them in live trading. They are very simply there for demonstration purposes. However, the way the function's been constructed gives you ideas on how to construct your own functions if you want to more or less make it more convenient to create an order dictionary for yourself. Now, the raise conditional order function essentially takes your investor account ID and takes an order. In this example implementation, when order is set to none, the function resorts to generating a dummy buy limit order. And this dummy buy limit order is specified as an investment of 200, which is the minimum on, for example, NTI, specifying NTI's full ticker symbol of NTI 0.4.12. The quote at which we'd like that buy limit to be executed. Buy limit meaning buy when price is less than or equal to specified quote. Threshold parameters being stop loss and take profit that will result in the generation of conditional orders on the investor account. And these are sell the investment at stop loss 100 at quote 100. And again, sell the investment if the quote hits 1000 in both cases, depending on the direction of the trade. And that's essentially it. So that raises the conditional order. It constructs the dictionary object in the specified format as in the API console, submits it as a post query to the API, and handles any exceptions if they happen along the way. And the rest of the functions here pretty much follow the same structure as the one we just saw for raising a conditional order. With the update conditional order, the request type is different, as we talked about earlier. It is a put request type, and here you need to construct yourself a DTO, and that dictionary object can be, again, done here through the dummy conditional update order if order specified is none. And this dummy order follows exactly the same format as all the other dummy orders, but has different contents. So in the case of the dummy conditional update order, we very simply specify any changes to the amount, the quote at which we'd like that conditional order to be changed to, threshold parameters being, would you like to change the stop loss, change the take profit to anything different, etc. And these can only be affected on orders that currently have status pending. Finally, you have cancel conditional order, which submits a delete request specifying the order ID in the endpoint itself, in the path, and you don't have to execute anything else. You don't have to send any data across via the delete request. Buy at market, again, same story here. We're sending across a post order with a dummy order generated for us if we haven't specified an order. And same is the case for sell at market. Close all account trades, as you know, is a simple stop out for following a post request type. And there are two types: close all account trades, in which case simply sending /stop out via post to the API will result in all accounts getting closed at that price, at their respective prices. All trades, all Darwins will be closed at their respective prices at that point in time, give or take divergence. And for close all Darwin trades, you can specify the Darwin for which you'd like to exercise the stop out, and then that will be affected via post as well. So let's go ahead and see how all of this works. Again, we need two things here because I don't remember my own demo account investor ID off by heart. So we'll create two objects. We've already created two objects for you. One is the DWX ACC info API, which is our investor account info API class. We've executed that on demo credentials, and same is the case for _trading equals DWX trading API, also on demo credentials. The first thing I'd like to do is get my account ID, as I don't remember it off by heart, and that can be done by executing get accounts. This gives us the account ID. So we're just going to, should have done that earlier, but we're just going to save that here in a variable called ID. And that's it. So that's our account ID saved away for us to do some things with it. We've also got open on the other side the account on the platform. So we can see once we create orders, be they conditional or at market, we can see them in execution either in the invested Darwins or the pending orders section, given the type of order that we've executed. So let's start with creating a conditional order. And for that, we will very simply go to raise conditional order, specify the account ID, which in this case is stored in a variable called ID above, as we just saw. And for order, we'll just resort to the default order that we have, the dummy order that we have in the code. So by specifying none, that dummy order will get raised. Once an order is raised, the API outputs the JSON corresponding to the order that was raised, along with some information such as the order ID and its current status, etc., dates and millisecond timestamps. So let's see if this has been executed. And in order for us to see that, we very simply go to the pending order section on the investor platform, and you'll see that the order to buy NTI at quote 200 has indeed been executed. And this has a stop loss of 100 and a take profit of 1000, as that is what we had specified in our dummy orders here. Buy limit order with a stop loss of 100 and a take profit of 1000. Now let's say I wanted to cancel this order because the price at which I've executed it, I've raised it, is quite far away. For demonstration purposes, we can very simply go to _trading._cancel this conditional order. In fact, let's update the conditional order first. And to update, again, you need to supply the ID of the investor account, and that is stored inside ID. And in our case, we've already prepared the dictionary for you in the code, the dummy order, and that will change the stop loss and take profit very slightly to 999.99. and the quote to 150, and that will then demonstrate how the update works. I forgot to specify the order ID, which in our case, when we submitted the order, was 30470 over here. So we'll simply add the 30470 to our instruction, and that will result in that conditional order getting updated. Whenever there is a successful operation, you will get the JSON back with the updated information, with the quote stop loss set to 100, take profit set to 999.99, and the quote changed to 150. If we now go back to the platform, you'll see that these values, once we refresh the page, have indeed been affected. So let's go to pending orders, where we are right now, and we have a buy limit now for amount 200 at quote 150 with a stop loss at 100 and take profit at 999.99. So this is all happening via the API. Now, since those quotes and everything related to those conditional orders are obviously example values and they're quite far away, it makes sense using these example values to cancel the order, because it's too far away and it's impractical to keep it for the moment. So we'll say _ID equals _ID. Again, we have to specify the order ID, which is the same, which is different now. It's 30471, as we've changed the conditional order. And that's pretty much it. We don't have to supply anything else, as this is essentially a delete request. Once we hit this, we'll get back a confirmation that the conditional order updated to status deleted as requested, and rejected reason is where that information is contained. If we now go on to the platform, we'll see that the pending order has disappeared from the pending order section. Now let's practice something to do with buy at market. So we've got _trading._buy at market. Again, we'll specify the investor account ID as _ID, and we'll set _order to none. This will make it convenient for us for this tutorial to execute an order at market, and that order will go on to NTI for the amount 200 at the current quote, with a crazy stop loss of 100 and a crazy take profit of 1000 for demonstration purposes. If we go ahead and do this, we should get a response back saying that the product NTI has been purchased with a stop loss at 100 and a take profit at 1000. The quote at which we got the price was 228. The quote which we got for this execution was 228.78. If we now flip over to the invested Darwin section, you'll see that in the demo account, NTI has been purchased at average quote 228.78. And the open P&L is 0, divergence is 0, as NTI is apparently not in the market at this point in time. And that's pretty much it. Now we've executed that order. Let's say we want to sell that order. We go to trading._sell at market. Again, specify the investor account ID. And remember, this is tedious for this example that we're doing on video here, but ideally you want to automate all of this so you don't have to keep typing in the ID every single time. And in this case, the order will set to none again, as we've already generated a dummy sell order that gets rid of the entire exposure we have to NTI at this point in time, which is the minimum 200. Once we hit this amount 200, product NTI 412, quote 228.78, the JSON returned confirms that the order has been sold at that price. And the moment we flip over to the screen, it refreshed and the investor Darwin section no longer has NTI. It should now be in history. So there's NTI that was bought and sold at the same quote without any movement. And that's pretty much it as far as raising, deleting, updating conditional orders is concerned. The other options that are left are closing account trades, which is pretty self-explanatory, and product market status that allows you to basically see what all you can do via the trading API at this point in time, and there's get leverage as well. So with the permitted operations, it's a case of simply hitting get permitted operations, providing you don't need to provide an investor account ID for this operation as we're not affecting anything. And there's allow buy, conditional sell, and sell, all of them set to true. So everything is available to you at this point in time. If you are interested in, for some reason, seeing your get account leverage, if you've forgotten it for any reason, you will need to provide your account ID, and that we've saved in _ID earlier. And this will return to us the current leverage on the account that you've connected to, in our case, the Temo investor account. And that's pretty much it. That is the entire Darwin Trading API implemented for you in Python, with the additional request types of put and delete also implemented in the base DWX API class and uploaded already for you on GitHub. So that covers all the APIs in Python 3. The project is now complete. So if we go in terms of implementation of core APIs, so we've got github.com/Darwinex. If we go over there to Darwin API Tutorials, under Python, you have the API directory. And in that API directory, all 5 APIs and their respective implementations in Python 3 now exist for you to consume in whatever shape or form that you'd like to. You would be advised to download the entire project as is, so you can continue the structure or modify it conveniently. However, should you not wish to do so, you can, of course, go to any respective API and download the functionality by simply clicking on the file in question, whichever API you're interested in, be that info, investor account info, quotes, WebSocket, or trading API. And that's pretty much it. So future tutorials will continue our efforts on the Darwin trading terminal construction that we started off in previous tutorials, as well as focus more heavily on trading strategy development and automating those strategies via the Darwin Trading API in the terminal as well as outside the terminal for standalone strategies. On that note, we'll also discuss how to automate the processing of your automated trading strategies using some examples such as how to set up a VPS to do so. If it's Windows, we'll talk about how to create batch tasks, scheduled tasks in Windows. If it's Linux, we'll talk about how to schedule cron jobs to run your strategy at particular points in time. If it's not completely automated and running forever through a console or through some batch process. But anyway, those sorts of topics will be covered in future tutorials, where we'll be discussing the actual strategy development and execution side of things. Thank you. As always, if you enjoyed this presentation, please do consider sharing it with your social networks, colleagues, co-workers, and friends. And do subscribe to the Darwinex YouTube channel so you remain up to date with all future videos that will be released in this series and other topics discussed on Darwinex. Thank you very much for your attention. See you next time.